This is the notes video for section 6.1, slides 10 and 11. All right, so in this part, we are talking about solving a differential equation. All right, so what that means is if I'm given an equation involving a derivative like f prime of x, all right, that's called a differential equation. And if I want to solve the differential equation, that means I want to find the original function. So I want to find f of x. All right, now it says that it needs to be subject to the initial condition that f of 1 equals -3. So what does that mean? That means that f of x is not going to be a general solution to the differential equation. It's going to be a specific solution to the differential equation because we have specified a particular value of the function. All right. So first thing we want to realize is f prime of x is actually the derivative of f. Right now, I understand that you know that f prime means the derivative of f, but if we write d f of x dx, okay, that is a little bit easier to understand when we say it's the derivative of f. All right. So the derivative of f of x with respect to x is 4x. Now, why am I rewriting it like that? Well, because in order to integrate, we actually have to have a differential on both sides of the equation. So I'm going to multiply both sides of the equation by dx. So I get df of x is equal to 4x dx. And so now I have a differential, the df of x, and the dx on both sides of the equation. So now I can integrate. All right, on the left side, I have the integral of the derivative of f of x. So I would get f of x plus c. Remember the rule we learned on slide 9. All right, and on the right side, the integral of 4x would be 4x squared over 2, or 2x squared, and then plus c. Now, if I have f of x plus c and 2x squared plus c, and I want to solve for f of x, I would, well, I guess I would subtract c, right? So I would get 2x squared plus c minus c. So does that mean plus 0? Well, no, it is not plus 0. Now, why is that? Well, what does c represent? Remember, c represents an arbitrary constant, meaning its value doesn't really matter. All right, it can be any value, it can be every value. All right, so if I have plus c here and plus c here, these c's are not necessarily equivalent. So what does that mean? If I take this arbitrary constant and bring it to the other side, I'm taking an arbitrary constant c, could be positive, negative, 0, anything like that, and I subtract another arbitrary constant. What I get is just an arbitrary constant. So what we're saying is that f of x equals 2x squared plus c. So when I do one of these differential equations, I actually will only add in c on one side, okay, just so we don't get confused and end up subtracting it out. Now, this is not our answer because we need f of 1 to equal -3. All right, and so how do I do that? Well, I plug in 1 for x, and -3 is f of x. So I get -3 is equal to 2 times 1 squared plus c. So that means that -3 is equal to 2 plus c, or c is equal to -5. So now, instead of saying that f of x is 2x squared plus c, I can say that f of x is 2x squared minus 5. So now this is our specific solution to the differential equation. So two things must be true about it. Number one, its derivative, f prime of x, must equal 4x, which it does, and f of 1 must equal -3. So 2 times 1 squared, 2 minus 5 is -3, so that is true. So that is the solution to the differential equation. All right, so that's slide 10. All right, now on slide 11, okay, now we're in a context, all right? So it says a particle is moving along the number line so that its acceleration at time t is a of t equals 6t squared. Find the position of the particle at any time t if v of 2 equals 3 and s of 2 equals 4. All right, so first thing we want to realize is that a of t, not a of x, sorry, a of t is the derivative of v of t, right? You could say v prime, but I like this differential notation, right? It's the derivative of v of t. It's also the second derivative of position, right? D squared, right? S of t dt squared, right? So we could say that. All right, so now first thing I'm going to do is I'm going to say, okay, well, if a of t is 6t squared, then that means that dv of t dt is equal to 6t squared, right? So the first step is to solve the differential equation, right? Remember, a of t is a derivative of v of t, so I'm going to solve for v. Then, once I have v, I recognize that v of t is the derivative of s of t. So I have ds of t dt. And so then, once I find v, then I'm going to find s by solving another differential equation. All right. So first thing, all right, so we have dv of t dt equals 6t squared. So I'm going to multiply both sides by dt. So I have dv of t equals 6t squared dt. All right, so now once I separate the differentials, then I'm ready to integrate. All right, so if I integrate dv of t, what do I get? I get v of t plus c, but remember, I'm just going to move the plus c over and only write it on one side. All right, so now 6t squared. All right, so that'd be 6t cubed over 3, or 2t cubed. All right, now I already said that I'm going to solve this differential equation for v, and then I'm going to solve that differential equation for s. So that means I'm going to end up integrating twice. So I'm going to have multiple c's. So I do want to distinguish them. So I'm going to call this one c sub 1. All right, so now I am told that v of 2 is 3. So I can use v of 2 equals 3 to find the value of c sub 1. So 3 equals 2 times 2 cubed plus c sub 1. So 3 equals 2 times 2 cubed. That would be 16 plus c sub 1. So c sub 1 is 3 minus 16, or negative 13. All right, so what does that mean? That means that v of t is equal to 2t cubed minus 13. Right? Now, we next need to realize or remember that v of t is the derivative of s of t, right? We just said that, ds of t dt. And so that equals 2t cubed minus 13. All right, so now, once again, just like earlier, we're going to multiply by dt. So I get ds of t equals the quantity 2t cubed minus 13 dt. Right now, I use parentheses so that we realize that dt is being multiplied by this whole thing. Then the next step is to integrate. So the parentheses are equally important because we have to remember that the integral applies to everything in there. All right, so now the integral of ds of t, of course, is s of t. And remember, plus c, but I'm only going to add it in on the one side. All right, so now the integral of 2t cubed. So that'd be 2t to the fourth over 4. So that'd be t to the fourth over 2 minus, what's the integral of 13? That would be 13t. And then I have plus c, but remember, we want to call it, I'm going to call it c sub 2. All right, so now I'm going to use the fact that s of 2 is equal to 4. So 4 is equal to 2 to the fourth over 2 minus 13 times 2 plus c sub 2. All right, so 4 equals 2 to the fourth is 16 over 2 is 8 minus 13 times 2, so 26 plus c sub 2. All right, 8 minus 26, right, gives us negative 18. So 4 equals negative 18 plus c sub 2. So now I add 18 to both sides, and I get that c sub 2 is equal to 22. So what does that mean? That means that s of t is t to the fourth over 2 minus 13t plus 22. So this is s of t that has an acceleration of 6t squared and has v of 2 equals 3 and s of 2 equals 4.